meter per hour. Velocity is given, that is 1100 kilometer per hour. At an altitude where the air temperature and the pressures are minus 35 degrees centigrade and temperature is and pressure is 40 kilopascal. Air leaves the diffuser at 50 kilopascal. This is P2 pressure with the velocity V2 of 15 meters per second. And combustion gases enters the turbine at 450 kilopascal. This is pressure P3, that is 450 kilopascal, and temperature T2 is 950 degrees centigrade. The turbine produces 800 kilowatt of power, 800 kilowatt of power, all of which is used to derive the compressor. Assuming an isentropic efficiency of 83%, isentropic efficiency of 83% for the compressor, turbine and nozzle. For the compressor, turbine and nozzle. Using variable specific heats, determine the pressure of combustion gases at the turbine exit, the mass flow. We have to find the pressure, mass flow rate, the velocity of the gases at the nozzle's exit, and the propulsive power, propulsive efficiency for this engine. Propulsive power and propulsive efficiency. Value of gas constant R is given to 0.287 kilojoule per kg dot K. First, we will draw the TNS diagram. Four, five, six. It is to be noted that enthalpy is a function of temperature only. Note that enthalpy is a function of temperature only, whereas entropy is a function of both only, where entropy is a function of both temperature and pressure. Temperature and pressure. Now first for that we will work for a diffuser. In the process 1 to 2. T1 temperature is minus 35 degrees centigrade, at which H1 is equals to 238.636 kilojoule per kg. H1 is plus V1 square divided by 2 is equals to H2 plus V2 square divided by 2. We will put the values over here. 238.36 plus 1100 divided by 3.6 divided by 2 whole square. This is kilometer per hour, so we are changing into meter per second. So dividing by 3.6 into 1 kilojoule per kg divided by 1000 meter square per second square is equals to H2 plus 15 meters per second square divided by 2 into 1 kilojoule per kg divided by 1000 meter square per second square. So from here value of H2 will be 284.93 kilojoule per kg. For this value of H2, P2 value is 50 kilopascal. For both, entropy value is 5.8, 513 kilojoule per kg dot K. Now for a compressor, process 2 to 3, pressure P3 is equals to 450 kilopascal and S3 is equals to S2, that is 5.8513 kilojoule per kg dot K. For this pressure and entropy, value of H3S is equals to 534.42 kilojoule per kg. Now the efficiency for a compressor is equals to H3S minus H2 divided by H3 minus H2. Putting the values 0.83 is equals to 534.42 minus 284.93 divided by H3 minus 284.93. So from here we will solve for H3 and H3 values come out to be 585.52 kilojoule per kg. Now for a turbine, that is process 3 to 4. Temperature T4 is given, that is 950 degrees centigrade, at which the value of H4 is equals to 1305.2 kilojoule per kg. At this value, we will calculate the value of H5 from the relation H3 minus H2, H4 minus H5. So from here H5 is equals to 1004.6 kilojoule per kg. By putting the values, that are 585.52 minus 284.93 equals 13.05 minus h5 and minus h5, and the value of h5 will come out with this. Where the mass flow rate for a turbine through compressor and turbines